Hey, so today we're going to do factoring integers, and we're going to talk about prime factorization and greatest common factors. So hopefully some of this is still a bit of a review and nothing too new, but still fun and exciting. So if I wanted the factors of 19, that really means that I want the numbers that multiply to get 19. So if I'm looking at 19, hopefully you know 19 is prime, which means 1 and 19 are really the only two positive numbers that you can multiply to get 19. But you also have to remember that negative 1 and negative 19 will also give you a positive 19. So I want you to remember that a negative pair of factors can always be the factors of a number, whether it's 19 or 24, 36, 48, or even 4, negative 2 times negative 2. But for now, we're only going to concern ourselves with the positive. We're going to focus on those positive integers. So if I want the factors of 64, I can look at them in pairs, and that's a good place to start. And so I could look at 1 and 64, or 2 and 32. 4 does not go into 64. Silly Miss Dancer. But, oh yes it does. 4 goes into that 16 times. I thought so. And then 8. And 8 goes into 64. 8 times, because 8 times 8 is 64. So those are the factors of 64. But what if I wanted the prime factorization of 64? I do apologize for my handwriting there. This is factorization of 64. So let's first make a little factor tree. Hopefully you've done that. And I'm going to go with that first factor pair that we just wrote down, which was 3 or maybe 2 and 32. So 2 and 32. 2 is prime. It can go no further. 32, on the other hand, I can continue to break down. So I know that 2 goes into 32. So I'm going to do 2 again. And 2 goes into 32 16 times. So again, 2 is prime, so I'm going to stop with that side, but 16 I can break down to 4 times 4, and then each of those 4s I can break down to 2 times 2. Okay, so the factor tree we get, but the prime factorization of 64, I want to use exponential form. And I want to say how many factors, like which numbers are prime factors, and how many of those I have. So the prime factors themselves are going to be our base. So in this case, we only have 2. So 2 is the base. My exponent is going to be how many times it is a factor. So it's a factor 1, 2, 3, 4, 5, 6 times. So the prime factorization of 64 is 2 to the 6th. So now let's do the prime factorization of 45. Well, 45 is 9 times 5. 5 is prime, so I'm going to stop there. 9, however, is 3 times 3. So now the prime factorization, remember I'm going to do exponential form, and I'm going to use my prime factors as the base. So I have 3 and 5, and then the number of times they appear at the very end, see how this is at the end and these are at the end, is going to be my exponents. So 3 appears twice and 5 appears once. So I can put that 1 there if I want to, but I don't have to.